Section 7.3, Confidence Intervals and Sample Size for Proportions. Proportions represent a part of the whole. It can be expressed as a fraction, decimal, or percentage. Proportions can also represent probabilities and can be obtained from samples or populations. That's where this fits into our statistics class. When we're working with our sample sizes for our proportions, we've got P represents the population proportion, and P hat is our sample proportion. If I want to know P hat, I'm going to take the X, which is what I'm trying to find, divide by the N, the sample size. Now Q hat is like the complement. Either you can take P1 minus P hat, or you can take your N minus your X, whatever you're trying to find, and minus that from your sample size. Again, still dividing by your sample size. For example, a random sample of 150 students found that 59 of them bought their own textbooks without aid. Find P hat and Q hat, where P hat is the proportion of the students who paid for their own textbooks. That P hat needs to be identified so that you can then identify what P hat is. So since it says 59 of them bought their textbook out of a total of 150, you can get then a decimal value by dividing numerator by denominator of 0.39. Now we can also write this as a percent. Okay. Q hat, on the other hand, you can go 150 minus 59 divided by 150. That will give you the same answer as if you were to take 1 minus 0.39. Okay? Giving you an answer of 0.61 or 61%. Here is the formula for finding a specific confidence interval for the proportion. Notice this time we're going to use P hat minus, we're going back to the Z values again, and then times the square root of P hat Q hat divided by N. Also notice that in order for us to use this, we need to take N times P, and it must be greater than or equal to 5, just like N times Q must be greater than or equal to 5. The rounding rule states that we need to round to 3 decimal places. A survey of 100 people found that 68% said it was hard to buy a gift to convey feelings. What we want to do now is find the 90% confidence interval. I'm going to assign P hat as that 68% of people having a hard time buying a gift to represent their feelings. That makes Q hat equal to 1 minus 0.68, which is 0.32. All right. Next, I need to identify Z sub alpha divided by 2. Again, we're looking for the 90% confidence interval. That gives me 1.65. I have all the pieces I need to then go ahead and find that interval. Taking P hat minus our Z sub alpha divided by 2. That should be 1.65 times the square root of P hat times Q hat divided by 100. That's sample size. And it's going to be between the population proportion of 0.68 plus that Z value, square root 0.68 times 0.32 divided by 100. Okay. One thing I found that when I was typing this into the calculator, that I actually would want to calculate this out and get that answer, and that was 0.077. Okay, and I can use that for the portion over here. Then in order to get my interval, I would go 0.68 minus that 0.077, and then 0.68 plus that 0.77, okay? To get an answer of 0.603 and then 0.757. You can be 90% confident that the percentage of people who find it hard to buy a thoughtful gift is between 60 and 0.3% and 75 and 7/10. Here's another example for you to look through in regards to that proportion. You'll notice that the key words are going to be find the confidence of the true proportion, hopefully giving you an indication that you're looking for the P hat and the Q hat. I'm always trying to find those clue words on to know what's the difference between each one, and that is definitely something to look for. Following along, they've identified what P hat is and Q hat. This piece right here, finding that critical value for that 90%, that's a reminder of how to do that, but you can always remember that that 90% is that 1.65. Then you can go to the next step. Once you have your Z value, you know P hat, you know Q hat, just substituting in those numbers. Again, knowing that your P hat is a decimal is a really key thing here. Following it through. Notice that the final answer, though, they did put it as a percentage. How we can say this then, you can be 90% confident that the percentage of students who pay for their college education by student loans is between 21 1/10 and 24 9/10%. Of course, there is a way that we can do this on the calculator. It is found under Stats. Then you go to Tests, and you're looking for 1 prop Z int. Basically, that's standing for proportion Z interval. Okay? They're going to want to know your number of subjects with that proportion you want, the number in your sample, and then your confidence level as a decimal. Here's an example that we can use to figure out with the calculator. You've got 45% of the adults say that dandelions are the toughest weeds to control, 95% confidence interval with true proportion, who say that dandelions were the toughest weeds. So P hat minus that Z value. We can enter this into the calculator, go under Stats, and then we're going to go over to Tests, and we're looking for that 1 prop T interval. You may have to scroll down a little ways to find that. It's right here under alpha A. Select Enter. Our X value, that's that proportion that we wanted to know. Since we knew it was 45%, I'm going to take 0.45, clear, 0.45 times how many people were in the survey, 1898. And then the number in the survey was 1898. My confidence interval was 95%. And then go down to calculate. I was wondering if it was going to do that. All right, so we actually have to figure out what that X value is. It's not going to do that math for me. So I'll go back to the Z prop. Okay, there's that A option. For those of you who want to go quickly to it, you can go alpha A. All right, I did the math of doing that. So I'm going to do 8454. It needs to be a whole number. I think that's part of the reason why our error occurred. So don't put in a negative or a decimal or negative. The C level still, let's see if it likes that better. much better. So again, I guess the moral of that story is make sure that you know what your X value is, and it does need to be a whole number. This is the formula for finding the minimum sample size to estimate a population proportion. If your p hat is given, use that value in the formula. But if p hat is not given, then use 0.5. Since this is the highest value, we can go, and it's equal in p hat and q hat. For example, I want a 95% confidence interval that my true proportion lies within 4%. Find the minimum sample size. If the sample of 200 people, 40 said they traveled overseas. That's part A. And then part B we're going to work through is if no estimate is given. Writing down the information, because we're working with 95% confidence, I know I'm using my Z value of 1.96. That 4% of the true proportion is going to be my E value. If I have a sample of 200, 40 traveled overseas. That means that my P hat is going to be 40 divided by 200. That is an answer of 0.2. Therefore, Q hat is going to equal 0.8. That tells me that my proportion I can use to find my sample size. So P hat times Q hat, and then times it, then times it by my Z value divided by my error, and then square it. This gives an answer of 384 and 1.16. We're talking about a sample size, so we need to round up to 385. Okay? That's if you're given the P hat. Now, what happens if you're not given the P hat? Well, if you're not given the P hat, then you need to assume that P hat is going to be 0.5. Since both P hat and Q hat are both 0.5, I'll substitute those into the formula. I'm still using that Z value of 1.96 and my error of 0.04. You can get an answer of 600.25. Again, we need to round up to 601. When you're given an estimate versus when you're not given an estimate, look at what happens to your sample size. It really does change it. It makes it more exact when you have more of an idea of how many people will have that situation occur. Versus if you don't know how many people, you're going to have to ask more people so you can get that confidence level in. This concludes section 7.3. Please go to your assignments and start working on them. If you have any questions, please let me know. Thanks.